we are going to integrate a function numerically and compare three rules. Our integrand is f of x equals the fraction 1 plus x times sine x all over x squared plus 4. We will find the area from x equals 0 to x equals pi. Then we will compare the rectangular midpoint rule, the trapezoidal rule, and Simpson's rule. Finally, we will show a table of errors relative to a highly accurate reference value. First, let us visualize the function on the interval from 0 to pi. Notice the function is positive here, so the area under the curve equals this integral. Let us start with the rectangular midpoint rule. We divide the interval into equal panels, and on each panel, we draw a rectangle whose height is the function at the midpoint. The sum of the rectangle areas approximates the integral. The midpoint formula is h times the sum from I equals 0 to n minus 1 of f of a plus I plus 1/2 times h. Next, the trapezoidal rule. Each pair of neighboring sample points forms the top of a trapezoid, and we sum their areas. The trapezoid formula is h over 2 times f of a plus f of b plus 2 times the sum from I equals 1 to n minus 1 of f of a plus ih. Finally, Simpson's rule. Now, we fit a parabola through every 3 consecutive points and integrate that quadratic exactly on each pair of panels. The Simpson formula is h over 3 times f of a plus f of b plus 4 times the odd index sum plus 2 times the even index sum. Now let us compute and compare the 3 rules. We will take the highly accurate reference value from Simpson with 20,000 panels. Then we will evaluate the midpoint, trapezoid, and Simpson for several numbers of partitions and print the results in 2 tables. Observe how the errors decrease as n increases and how Simpson's rule converges fastest. Summary: the rectangular midpoint rule is simple and decent. The trapezoidal rule often improves the estimate. Simpson's rule uses parabolas and typically converges far faster on smooth functions. For our integral, all 3 approaches agree closely as the number of partitions grows.